Hey friends. Okay, so we are now in lesson 6 of rational expressions and equations, and this is where we turn our attention to the equation portion of rational expressions and equations. Okay, so we've talked about what a rational expression is, and then we've done mathematical operations on rational expressions. We've done adding, subtracting, multiplying, dividing. In all of that, we've been practicing our factoring skills. We've been talking about restrictions, how we can't have a zero on the bottom of a fraction, all of that sort of stuff. And yeah, now we're good to go with equations. Now, what makes an expression turn into an equation? And the answer to that question is an equal sign, okay? The only difference between an expression and an equation is that an equation has an equal sign. So in some sense, it's like you've got the left and the right side are expressions, and then there's an equal sign in between. Now, that equal sign is very powerful, right? It means the left side is the exact same as the right side. So that allows us to do some algebraic manipulation in order to solve for things, right? If I add 5 to one side, I'll still be equal as long as I add 5 to the other side as well, okay? And so when we go to solve these things, we can use some of those tools to help us get to a solution. So one method to solve a rational equation is to now take a look. These look hopefully starting to feel similar to other things we've talked about. Factor completely. That's always been my number one thing. Number two, determine the common denominator. And then I'm going to actually show you two different ways here. Step 3 says multiply all the terms in the equation by a common denominator. Some teachers teach to multiply everything by a common denominator. Some teachers teach to actually write it as a common denominator first and then pull the numerators. I'm going to show you both of them just so that no matter who is your teacher, you'll be comfortable with whichever method. Okay. You also have to pay very, very close attention to your restrictions. Okay. These questions are not going to say to you, hey, friends, don't forget your restrictions. It's assumed that you're going to look at restrictions. And then when you get to your answer, you're going to go back and you're going to make sure that your answer is not one of the restrictions. Okay. Okay, so we're just going to take a few baby steps here for a second and just practice multiplication, practice some of the steps we need in order to solve. Okay, so if I gave you 12 times 3x minus 5, you would tell me that that's 12 times 3x and 12 times negative 5, right? Remember that if there's a negative in front, or if it's a subtraction sign in front, you treat that as a negative. Okay, so that's going to give me 36x and then minus 60. 36x minus 60. Okay, cool. Next one up. 12 times 3x over 4 minus 5 over 3. Now, again, it's still the distribution law, so it's still going to go 12 times this. But when you're doing that, you can go 12 times 3 divided by 4, which you can totally do in a calculator, right? I'm actually going to go the other way, though. It actually doesn't matter. I'm going to go 12 divided by 4 first, okay? Because it's just going to make my number smaller. So 12 divided by 4 is 3, and then I'll multiply it by that 3. So that's going to give me 9x. And then 12 divided by 3 is 4. And if I multiply that 4 by the subtraction of 5, that'll give me minus 20. Okay, so that would get me 9x minus 20. 9x minus 20. Okay, so then if I had something like this, now, again, this isn't too complicated yet. You've been solving equations like this for a little while, but I'm going to distribute the 12. Oh, actually, do you know what? I'm not going to distribute the 12 because I just noticed I'm multiplying by 12 on the other side too. So actually, I could just essentially divide both sides by 12. Okay, so 12 divided by 12 is 1, and 12 divided by 12 is 1. Okay, that's actually easier than doing the distribution. Okay, again, I'm following algebra rules. Whatever I do to one side, I do to the other. I chose to take the left side and divide by 12. I'm taking the right side and dividing by 12, so I haven't changed the equality statement. That's going to give me 3x minus 5 equals 7. Then I just need to add 5 to both sides. So that'll be 3x equals 12. And then divide both sides by 3, and that'll give me x equals 4. Easy peasy lemon squeezy. Okay, so solve the following equations. Now I'm just hide my head for 1 second. State any restrictions and verify your solutions. Okay, so the first thing I'm going to do is think about what would be the lowest common multiple between 4, 3, and 2. That's how I usually get a common denominator, right? It doesn't have to be the lowest common multiple, but it just makes your life a whole lot easier if it is. So I'm asking myself essentially, what's the smallest number that I can turn 4, 3, and 2 into through multiplication? And that would be 12, okay? 4 times 3, 3 times 4, 2 times 6. Okay, so least common multiple is 6. Or sorry, 12. I got thinking about that 6 that I last said. Sorry about that. Okay, so in this first method that I'm going to talk about, and this was the method that we outlined at the beginning of this note, I'm going to now take both sides and multiply it by the least common multiple. So I'm going to take my left side, multiply it by 12, my right side, multiply it by 12. Now, this 12 serves a purpose. So it's not like in that last example where I say, oh, I'm going to divide both sides by 12 now. I mean, I can, but you just walked yourself around in a circle, right? What I want to do here is say, okay, 12 divided by 4 is 3, so that gives me 9x, because then I multiply by the 3, okay? 12 divided by 3, okay, so now I did that, now I'm doing this guy, right? So 12 divided by 3 is 4, times the minus 5 is negative 20. 12 divided by 2, right here, is 6. 6 times 7 is 42, okay? So then I'm going to add 20 to both sides. So that'd be 62, and then divide by 9. So 62 over 9 would be my final answer there. Okay. All right. Just bring that up here. Perfect. Okay, next up. The second method is to actually create the common denominator first. Okay. Now, the common denominator is 12. So I would say, okay, let's set everything up as a fraction over 12. And I'd say, okay, how do I go from this 4 over to that 12? I multiply by 3, so that becomes 9x on the top. Whatever I do to the bottom, I have to do to the top, right? How do I go from 3 over to 12? I multiply by 4, so this is going to become a 20 there. And then how do I go from 2 over to 12? I multiply by 6, so whatever I do to the bottom, I have to do to the top, okay? And then there's this concept, once I have a common denominator, that says the following. Essentially, if 2 over 3 equals x over 3, then x has to be 2, right? Because 2 over 3 doesn't equal 4 over 3. So once I have a common denominator, it means that my numerators actually have to be the same thing. So I can just pull my numerators out and solve from there. Okay, so that's what I did. I just pulled my numerators out, and now I'm going to solve. And if you remember from the last slide, I'm right back to where I was on that last slide now. I'm going to add 20, and then I'm going to divide by 9. Okay? Yay! Now, to verify. To verify means I'm going to plug in what I think my answer is back into the original equation just to show that it works, okay? When we do verification, you'll notice I have a line here. It's not great practice. Some teachers don't care, but it's not great practice to be putting equal signs on the left and right side in a verification, because actually that's what you were asked to figure out. You were asked to show that they equal each other. So we shouldn't start with an equal sign if we're asked to prove that something equals, okay? So instead, you just work with the left side by itself, work with the right side by itself, and then ensure that they end up being the same thing, okay? So I'm going to plug in 62 over 9 for x. So I've got the left side all set up. The right side is just going to be 7 over 2. So I actually don't have to do anything with that guy. All right, so what I want to do first here is I actually want to see if I can make my life just a little simpler by reducing. Take a look at this. 4 and 62, I could divide both of those by 2, and that would give me 2 and 31, right? And then 3 and 9, I could divide both of those by 3, and that would give me 1 and 3. That's going to be a little easier to deal with mathematically. So that's where I end up with the 1 over 2 times 31 over 3. Okay. Now, I also needed a common denominator, so I kind of did that right away. I said to myself, hey, look at this. My common denominator is going to be a 2 and a 3 on the bottom. So this guy needs a 2. And now both denominators have a 2 and a 3 on the bottom. Okay. Now, I'll actually do the math here. So this is going to be 31 over 6 minus 10 over 6. Just multiply the tops, multiply the bottoms. 31 minus 10 is 21. So 21 over 6. And then 21 over 6 reduces to 7 over 2. Okay. If you don't believe me, I'll show you. 21 over 6. Both of those are divisible by 3, right? And then that would give me the 7 over 2. Right. Awesome. Once you have a verification done, you have one more thing to do, and that's make a concluding statement that says left side equals right side. Okay, so the left side equals the right side. And now we've proven it. Okay, good. Now, the next one, this is kind of a special case. It's a special case because it's a fraction equals a fraction. Now, I don't know what your teacher is like. Very seldom do I ever allow kids in my class to say cross multiplication because they usually say it in the wrong context and they don't do it right. Here is the one time when I would allow you to say, oh, I could cross multiply that. And you do it when you have a fraction equals a fraction. If there's no other term here, it's just one fraction equals one fraction, then essentially you can multiply the diagonals together. It's essentially like you're getting rid of a 2 by multiplying both sides by 2, and you're getting rid of a division of 3x minus 1 by multiplying both sides by 3x minus 1. Okay. Now, we do need to talk about non-permissible values because there's a variable on the bottom here. So I know that x can't be 1/3. Again, if that stresses you out, I want you to go back and review how to get restrictions from our previous video. Okay. And now I'm going to do the multiplication. So 2 times 5x minus 4 equals 3 times 3x minus 1. Okay. Now I'll distribute the 2 and distribute the 3. So this is going to be 10x minus 8 equals 9x minus 3. Subtract 9x from both sides. That's going to leave me with just x on this side. And then add 8, because I have to get rid of the subtraction of 8, right? So add 8 to both sides, and that's going to give me 5 on the other side. So x equals 5. Now, that's not an MPV, so that's good. And now I'm going to verify. So I'm going to verify that x equals 5. I'm going to plug in 5 back to the original equations. Okay, so I end up with 5 times 5 is 25 minus 4 is 21. And then 3 times 5 is 15 minus 1 is 14. So 21 over 14, both of those are then divisible by 7, which gives me my 3 over 2. Yay! And then I can conclude left side equals right side. Okay? Left side equals right side. Always, always have that at the end of your verification. All right, good. Let's just add another layer. Each time I'm just building you up, up, up. We're getting deeper, deeper, deeper. Can you go up and deep at the same time? I don't know. Anyway, you get what I'm saying. Okay, 18 over x squared minus 3x equals 6 over x minus 3 minus 5 over x. Now, I've been ignoring for these first two examples, I've been ignoring step 1, guys, because there was nothing to factor. But there is something to factor here. So I'm going to go ahead on this bottom left and take out an x. So I have that in factored form. So that'd be 18 over x times x minus 3. And then I don't do anything to the other side because there isn't anything to do with the other side. But hey, that was actually super helpful because now I can see that this actually is my common denominator, right? So my lowest common multiple, which will be my common denominator, is going to be x times x minus 3. Now, I'm going to go through this by multiplying everything by x times x minus 3, okay? If you like getting a common denominator better, that's totally fine as well. But if I multiplied everything by x times x minus 3 on this first guy, then my x minus 3s would divide out, right? So I'd just be left with 18. Over here, just the x minus 3s would divide out, and I'd be left with a x. And here, the x would divide out, and I'd be left with an x minus 3. Okay, so that's going to leave me with 18 equals 6x minus 5 times x minus 3. Now, I can distribute the negative 5. So that'd be negative 5x plus 15. Watch that. Okay. And then I see 6x minus 5x is 1x. And I could subtract 15 from both sides. That would give me x equals 3. Okay. Now, take note, friends. X equals 3 is no bueno because it's a non-permissible value, which means I have found something called an extraneous root. Extraneous root. Okay. Now, what I super care about is not actually that you can spell extraneous, but that you tell me that there's no solution. Okay. And tell me why you know there's no solution. So you have to interact with the fact that x actually can't be 3. So I said no solution as x can't be 3. Okay? Yay. All right, let's try this one. Again, step 1, let's do the factoring. I see that x squared minus 9, and that's a difference of squares. So that'll be x plus 3 and x minus 3. Okay. That's a little typo over there, friends. Let's just get rid of that x. Pretend you don't see that there for me, okay? Okay, so now x plus 3, x minus 3 is actually going to be the common denominator. We got to talk about non-permissible values. X can't be plus or minus 3. My least common multiple, my common denominator is going to be x plus 3, x minus 3. Okay. And then if I multiply all of this by x plus 3, x minus 3, well, what's going to happen? This guy, my x plus 3s will divide out, and I'd be left with 2x times x minus 3. This guy, my x minus 3s would cancel out, and I'd be left with x times x plus 3. And then this guy, both of them would cancel out, and I'd just be left with my 18. So when I go ahead and do that, I end up with this statement, which is sort of what I just wrote up there, right? Okay, so that's going to give me, I have to distribute the 2x and distribute the x. So that'll be 2x squared minus 6x plus x squared plus 3x equals 18. Now, 2x squared plus x squared is 3x squared, just combining like terms here, right? Negative 6x plus 3 would give me negative 3x. And then the other thing I did was just bring my 18 over because I can see here that it's going to be a quadratic, and I know that I want to try and factor. And to factor, everything has to be on one side, and it has to equal 0. Okay. So the other thing I want to do to make my life a little easier is divide everything by 3 now. I can do that because essentially I'm just dividing both sides by 3, right? So if I went, boom, I'm going to divide all that by 3, and I'm also going 0 divided by 3. It's just that 0 divided by 3 happens to be 0. So that's going to give me x squared minus x minus 6 equals 0. Now I want to factor that. So I'm looking for two numbers that multiply together to give me negative 6, add together to give me negative x. That'd be negative 3 and positive 2. And so I end up with a factor x minus 3 times x plus 2 equals 0, which means x equals 3 and x equals negative 2. Then I go check my NPVs. Oh, x can't be 3, so I'm going to scratch him out and just conclude that x equals negative 2. Okay. Now, I want to verify this guy. Notice I didn't verify the last guy because there was no solution. There really wasn't anything to verify, okay? But this guy I will verify, so I'm going to plug in -2 everywhere where I see x into the original equation. I've got that straight line where my equal sign is. I don't want to put an equal sign there yet because I want to prove that they actually are equal to each other. Okay, 2 times -2 is -4. -2 plus 3 is 1. -2 minus 3 is -5. So I'm looking at something like that. I want to get, I'm just going to stay on this guy for a sec. I want to get a common denominator here. A negative divided by negative is a positive, so I can actually, these two negatives divide out. So I'll just be left with 2/5 there. So why don't we get a common denominator? Why don't we turn this 1? I'm just trying to get ink on here, sorry. Why don't we turn this 1 into a 5 by multiplying by 5? So whatever I do to the bottom, I have to do to the top. Okay, so that's going to give me -20 over 5 plus 2/5. So that would be -18/5. Okay, on the other side, if you take a look at what's going down here, -2 squared was +4. And then 4 minus 9 is -5. So both sides give me -18/5. Yay, I have verified it. But remember, I have to conclude left side equals right side. Okay? See, we can totally do this. Okay, so let's summarize. I'm just going to hide my head for this first statement. To solve a rational equation means to find the solutions or the value or values of x that makes the statement true. That is what a solution is. Okay, to solve a rational equation, first, everybody's favorite F word, factor everything. Then you're going to find a common denominator and you're going to multiply all terms by that common denominator. And then at that point, if we've done that right, you won't have any fractions. Okay, then simplify and isolate for the variable. Remember, I'll just hide my head again here. Remember, we must always check the solution with the restrictions. If our solution is one of our non-permissible values, then we have an extraneous solution. Okay, we should always verify our work by substituting our solution or solutions back into the original equation, and we could check by graphing if we wanted to do that as well. We haven't spent a whole lot of time on graphing yet, but we will as we go into other units. Okay. If we end up with any term bigger than x squared, such as an x cubed or an x to the 4, probably what happened there is you didn't make the simplest common denominator, right? We want that common denominator to be as small as possible. So just go back and check your work, okay? And if you really want to cross multiply, this can only be done when there's only one term on both sides of the equal sign. So when you have a fraction equals a fraction, that's the only time you have permission to talk cross multiplication, okay? All right, friends, that is it for me. And now it's time for you to do some work. So you've got lots of practice there. Make sure you connect with me if you do have any questions, and make sure you're checking your answers and get feeling really solid about this stuff, okay? Thanks for watching. Thanks for letting me take this journey with you. I really enjoy it. And thanks for sharing these videos with your friends. And of course, thank you for subscribing to my YouTube channel. You guys got this. I'll see you for the next video, which is going to be on applications. It'll be super fun. Applications is a fancy way of saying word problems. Yay! See you then.